Okay, let's try a couple of application questions. So this particular one, you've got a sheet of paper, 0.1 of a mil thick, fold in half, it's clearly twice as thick, fold in half again, it's twice as thick again, and you keep on doing that repeatedly. So, let's answer the questions. Number one, let's find a rule that relates the thickness to the number of folds. So, what we'll have here is so we'll come up with some particular function, some rule that the thickness after a certain number of folds. Now, it's growing exponentially because it's doubling each time. Twice as thick again. It's an exponential growth. Things that grow exponentially always have this particular pattern to them. It's whatever the initial value is multiplied by the growth factor. So, the initial factor, I'm going to let capital T stand for the thickness. So, I put a little subscript 0. So that means capital T for thickness, subscript 0 means the initial thickness, the starting value, in this case 0.1. And that gets multiplied by the growth factor. In this case the growth factor is a doubling factor. So it's being multiplied by that growth factor, and that growth factor happens every time that you have a fold, or enters the number of folds. So there's your rule. Well, if I can now fill in what the initial thickness is, so that's the rule. So what I really need to add in here for good communication is this. So that's the rule where T is thickness in millimeters. So you must state what the variable is that you're using and the units that it's in, if there are any units. And N is the number of folds. Voila, I've done A, I now have the rule. Let's try B. So for B, we want to fold it 10 times. It's simply a matter of taking that N out and putting 10 in its place. So plug it into your calculator, 102.4 mils. Now, I like you to have good communication. Just writing 102.4 mil is not a good way to say it. It's 102.4 mil, so thickness is so it's good to put that in. Actually state the question in your answer. So do the calculations, so therefore thickness is 102.4 mil after 10 folds. So just stating a number is not an answer to the question. Putting that number in the context of the question is an answer to the question. So please be aware of that. And then C. In a moment I'll clear the board a bit and we'll talk about C. Now, C, we want to find how many folds to reach 6 centimeters. If we go back to the original question, I've rubbed it out here, but once you stated your rule, I said thickness, T was thickness in millimeters. I don't have millimeters, so I now need to convert that to millimeters. So that's a key thing you need to watch out for. So when you develop your rule and you write down what each variable stands for and the units, it helps you to watch out for things like this. So I can now go through and use my rule. So the thickness I know to be 60 mil. The rule is 0.1 times growth factor to the power of n. N is what I don't know. So rearrange that now, divide both sides by 0.1. Now I have my unknown up here in the index line. Whenever you have an unknown in the index line, warning bells need to go off in your head. That's a surefire way of knowing you need to use logarithms. I need to take logs of both sides. Now, your calculators don't do logs other than base 10 and another number base e, which we come across next year. The easiest thing to do, because this power is in base 2, it would be easiest to take logs of base 2, but your calculator can't do that. It doesn't matter. We can take logs any base we want and it'll still work out. So at the moment I haven't written a base in, so therefore everyone knows that I must be using base 10. That's right. So I'm going to apply my power law of logarithms here on the right hand side. I now have two numbers multiplied together where one of them is my unknown. I take the other number across as a divisor. Now, since they're both in base 10, you can do that on your calculator, and that comes to approximately 9.23. So therefore, 9 folds won't make it to 60 mil, so therefore I'm going to need a 10th fold. Right. So there's your 3 questions. So this first one was an exponential question where you had to generate your own rule. In a moment, I'm going to put up another one that's a logarithmic question where the rule's given to you. So give me a moment, I'll clear the board and I'll be right back. So this particular example, this time you don't need to generate a rule, the rule's been given to you. I just cut the question down just for time and space, but this is a function that tells me what the price of gold is a certain number of years after 1980. So P is price of gold per ounce in dollars, T is time in years after 1980. So first question is, what was the price in 1980? Well, that means our T value has to be 0 because that's 0 years after 1980. So fill it in, see where it leads. So 5 times 0 is 0, 0 plus 1 is 1, so 400 plus 50 log 1. We know that the log of 1 is equal to 0, 0 times 50 is 0, so the initial price in 1980 was $400. So, second question, what's the price of gold per ounce in 1999? So, step 1, work out your T value. How long after 1980 is that? It's 19 years. Plug that into your formula. 400 plus 50 log 5 times 19 plus 1. So 5 times 19 plus 1 is 96. Plug that into your calculator and you get $499.11. Now, just once again for time, I really haven't answered either of these correctly. I should have said here, therefore the price in 1980 was $400. Therefore the price in 1999 is $499.11. We'll take that as understood for now. Alright, put C up for you. So, when will the price exceed 550? So this time we've got to work out time we've been given price. Just start moving numbers from the right to the left. Take the 400 over. The 50 at the front's a multiplier, take it over as a divider. We know the log is in base 10 because it's not written in there, so I'm going to change it from a log statement to an index statement. From there, it's a simple matter of rearranging to make it read T equals 10 cubed is 1,000. Take 1 off both sides, divide through by 5, left with the time. So it's going to be approximately 199.8 years. So therefore, price will exceed 550 in, so 1980 is the base year, add on about 200 in the year, in about the year 2180. And then the type of problems you're going to come across. Now I'm not going to give you any entry card questions for this particular one because they're all sort of quite involved. So I think it'll just be a matter of just turning up. I'll have a look at your notes, have a look at the comments that you've made about what you understand, what you don't understand, and what statement you've made about what you want to be able to do for this particular lesson. Okay, I'll see you in class with these.